Okay, good afternoon class.
Good afternoon, ma'am.
Today the topic of discussion is Ionic Equilibria, in which we are supposed to discuss about electrolytes, then pH of the salts of weak acids and weak bases, and hydrolysis. So before getting into the topic of class, I would like to recall what we have done in the previous class. Okay, in the previous class we have done Lee-Chatelain principle. Okay, and in this what we have done, we have discussed about the effect of concentration, how it is going to affect your equilibria. We have talked about pressure, then we have talked about temperature. We have also discussed the effect of inert gases under two conditions: if pressure of the system is kept constant, if volume of the system is kept constant. And the last was the effect of catalyst. Catalyst does not affect Ka value, your dissociation or equilibrium constant, but it alters the rate of forward reaction and backward reaction. This is what we have done in the last class. And there was one topic which was left, which I want to discuss today, is just write down degree of dissociation and vapor density measurements. Degree of dissociation and vapor density measurements. How you can use your vapor pressure of certain substances to calculate the degree of dissociation of that reaction. Okay. Now what do we mean by degree of dissociation? It is represented by alpha, that we know. Okay. Degree of dissociation means the number of moles of any substance in which you are working. Number of moles of the substance dissociated divided by the total number of moles of substance taken. Okay? This is the number of moles which has dissociated divided by the total amount which you have taken. That is nothing but your degree of dissociation. Now we are going to use, to calculate, instead of taking the number of moles, we are going to use vapor pressure to calculate your degree of dissociation. Now we know that, okay, let us consider that PCl5, which is in gaseous state, undergoes dissociation to give you PCl3 and chlorine gas. Okay? So this is how your dissociation is happening. If I say that the initial concentration of PaCl5 is 1, I am just assuming it to be 1 mole. 1 mole is undergoing dissociation to give you 1 mole of PCl3 and 1 mole of Cl2. Then what we need to know, that concentration at equilibrium. Okay, we need to know the concentration at, let us say that alpha is the degree of dissociation and alpha amount of PCl3 has been dissociated. Similarly, alpha amount of Cl2 has been dissociated. So this would become 1 minus alpha. So this amount has been left after dissociation. So degree of dissociation would be, then in that case your equilibrium constant would be alpha square upon by 1 minus alpha. If I am interested in calculating the concentration of these species at equilibrium, what I will do? I will multiply simply with the concentration of PCl5 given to us. If it is 1 mole, what I will do? I will multiply this with 1 molar. Then it will be alpha molar. That would become alpha molar. So I want you to write down, let us say alpha, your degree of dissociation can be measured, degree of dissociation can be measured from the vapor density, degree of dissociation can be measured from the vapor density, ठीक है. Now this is what we have done. उसके आगे लिखो, suppose that after this, suppose that the initial volume or the volume occupied by per mole of the substance is V. ठीक है. The volume occupied by per mole of a substance is V. Since we have only 1 mole of a substance, so your initial volume would be, क्या हो जाएगा? That will remain V only. ठीक है. Now let us calculate the total number of moles after dissociation. That would be this amount, 1 plus alpha plus, sorry, 1 minus alpha plus alpha and plus alpha. These are the total number of moles. We are not doing number of moles left. उसके लिए what we'll do, we do the number of moles of product minus, that talks about the change in the number of moles. Here we are interested in the total number of moles present in your reaction. So this would be your this, so it will become 1 plus alpha. So the volume for this number of moles will become this into V. हाँ. So final volume, we call it to be. इसके आगे लिखो. Now we know density of, what is density? Density is mass upon में volume, or you can say your density is inversely proportional to volume. Okay, this is the equation. Let me say the density of the system before the reaction, or initial density of the system, is represented by D only, and the volume which you have calculated, the initial volume, is nothing but your V. So this would be your first reaction. Okay, or this is the density of the system before your equilibrium has been established, or at the initial stage of the reaction. Second is, let me say the density at equilibrium is represented by small d. In that case, volume is nothing but this quantity. So this is V into 1 plus alpha. Let me say this is your second expression. Now what I'll do, I'll take the ratio of these two, density by this. So this will become 1 by V divided by 1 upon me V into 1 plus alpha. Okay. So on solving this further, we'll have in the expression as 1 by V into 1 plus alpha into 1. We say V will get cancelled, so we will be left with this expression. Okay. So knowing the density of the system before, or initial density of the system and initial density of the system at equilibrium, you can calculate the degree of dissociation. You can solve this further. This become d by d minus 1. So this is d minus d upon me. Okay. This is clear how you can use the density, and density is nothing but related mass of the substance. That is the observed mass which you observe out of certain experiment or out of certain calculations. Okay. This you are going to calculate using your molecular formula. This is the observed mass which you observe. Okay. You just replace, this is your density only. Okay. So density is nothing but m by 2. What you are going to do when you are replacing, let me say this is the density initially, that is the initial density, d is the initial density of the system. Okay, you can calculate the initial mass of the system using this expression. तो जब आप density को replace करोगे, you will get mt by 2. Okay. Similarly, you can have the density of the system at equilibrium. Let us say that mass is represented as m naught. So when you substitute this and solve it further, I have just missed the steps, I have given you the expression directly, you will get this expression. Okay, because 1 by 2 will come here, 1 by 2 will come here. When you will take it out, that will get cancelled with the denominator wala 1 by 2. Okay. Okay, write down a numerical which will make you concepts more clear of dissociation. Abhi to I'm like telling you the result here because I don't want to waste the time on the calculations, but this is the way you're going to proceed when you are given with the vapor densities or the molecular mass or any of the two. You can use that to calculate the degree of dissociation of the system given to you. So this will come out to be 0.425, 0.485. Okay. Okay, when this is the degree of dissociation, if I want you to convert this into percentage degree of dissociation, what you will do? Into 100. That will get converted into the percentage degree of dissociation. So this is the last topic which was left in the last class, which I was not able to complete because of the lack of the time. So with this, your journal equilibria is over. Generally, like we have talked about equilibrium constant using your what? Equilibrium equation, which says your equilibrium constant is nothing but the ratio of concentration of products by concentration of your reactants. Okay. Then we have talked about representing the same equilibrium constant in terms of pressure when you are dealing with the gaseous reactants and gaseous products. Okay, that is your Kc, that is your Kp. Along with that, we have done Qc and Qp. Sorry, this is Qp. These are nothing but the reaction coefficient. They are calculated at a particular instant of time. They will vary during the course of reaction, but our equilibrium constant will remain same. Then what we have talked about? लीच-एटलियर प्रिंसिपल. And how does all the factors लीच-एटलियर्स के अंदर आपका like pressure, temperature, concentration, catalyst and inert gas vary your these factors, and how does their variation will shift the equilibrium from either to the forward direction or to the backward direction. And the last topic was your vapor density measurements and degree of dissociation. With this, your journal equilibria is over. Today we'll start with ionic equilibria. Okay. Okay, whenever I say the term ionic equilibria, the first thing which comes to your mind using the word ionic equilibria is what? When I'm saying ionic equilibria, ions, equilibrium which involves more of ions. Okay, abhi tak like the reaction which I have written here, PCl5 giving you PCl3 or Cl2, that was giving you molecules, not the ions. So that you can categorize under a journal equilibria. There are certain equilibriums in which it dissociates to give you ions. For example, sodium chloride, which is your common salt, it dissociates to give you sodium ions and chloride ions. HCl, which is a strong acid. Okay, it dissociates to give you H plus and Cl minus. Okay, let's take one more example. Acetic acid, it dissociates to give you acetate ions and hydrogen ions. But in this particular reaction, your dissociation is not complete. Whether in case of sodium chloride and HCl, your dissociation was complete. So that was giving you the concentration of, in case of acetate ion and H plus ion, that there would be an equilibrium, or it will get dissociated to a smaller extent if you compare that with HCl or NaCl. Okay, so starting with ionic equilibria and the topics which we are supposed to complete is electrolytes. Then pH of not feeling good, someone is like suffering from diarrhea, हम electrolyte देते हैं ना उसको, ORS देते हैं, that is an electrolyte. It gets completely dissociated. It supplies you sodium ions which are necessary for the working up of your system finally. Okay, so electrolytes, whenever we say electrolytes, the electrolytes are something which undergoes dissociation. ठीक है. Then electrolytes के अंदर there are two categories. One is the electrolyte which conduct electricity, one is the non-electrolyte which do not conduct electricity. Okay, so there are two kind of electrolytes. You have electrolytes and you have non-electrolytes. Okay, electrolytes are the substances whose aqueous solution, when I am saying aqueous solution, that means I am using water to form their solution or their melts. What do we mean by melts? molten state, not a proper liquid state, but you can say that is close to liquid. Okay, their molten state or their aqueous solution conducts electricity. It conducts electricity. Whereas in case of non-electrolytes, they do not conduct electricity. Okay, they do not conduct electricity. Okay, if I want to put some example under the category of electrolytes, what I can say? Sodium chloride, okay, HCl, acetic acid, and many more examples will come to you. If I put some examples in non-electrolyte, you can have a, say, aqueous solution of sugar. ठीक है? Anything which remains in its pure state, which does not undergo dissociation, that would be termed as non-electrolyte. Further, you can divide your electrolytes into two categories. One is your strong, yes, weak also. One is your weak electrolytes, and the other one is strong electrolytes. Okay, strong electrolytes means there is complete dissociation. In case of weak electrolyte, what kind of dissociation would be there? They are partially dissociated. Okay, when you represent a reaction for strong electrolyte, let me say your sodium chloride. Sodium chloride is a strong electrolyte. It undergoes dissociation to give you sodium ions or chloride ions. Okay, weak electrolyte के अंदर you have an example. Simplest example is acetic acid, and you represent it like this. Okay, so what is the difference between strong and weak? The kind of representation is like you are going to use a one side arrow for representing the dissociation of your strong electrolyte. In case of weak electrolyte, you are going to use, that means there is some kind of equilibrium in this case of acids. Weak acid may you will always have an equilibrium, or if you want to calculate the equilibrium constant in this case, that equilibrium constant is nothing but your ionization constant. Okay, so this is how the classification of electrolytes proceeds. Then we have certain things which we need to discuss in this, like when the course of the reaction, course of the class will proceed, we'll talk about their ionization constant, we'll talk about what is dissociation, how it is different from ionization, can we compare dissociation and ionization, then how to calculate the pH of a weak acid and weak base. You can have certain solutions in which you have strong acid as well as a weak acid. You can have certain solutions which undergo dissociation to give a strong acid and a strong base. You can have certain solutions which undergo dissociation to give you a strong acid and a weak base. So these are the certain cases which are going to discuss as we proceed in the class. Okay, so first thing which we are going to talk is ionization constant. Since we are talking about ionization constant, there should be some kind of ionization. Okay, what is the difference between ionization and dissociation?
Some dissociation is when the molecules are earlier they are not in the ionic form, and ionization earlier also they exist in the ionic form and then they separate them, and in dissociation they exist as a molecule and then they dissociate.
You have said completely fine, but in an opposite way. Okay, जो बोला है ठीक है, but if you have explained ionization instead of dissociation, that would have gone completely correct. Dissociation means it has just dissociated the molecules. Okay, ionization matlab it has led to ionization. Dissociation may, for example, sodium chloride, it is always present in form of sodium ions and chloride ions in its solid or a melt. You can always represent sodium chloride like this. Okay, there are strong electrostatic interactions, and when you dissociate this, it gives you sodium ions and chloride ions. Whereas HCl is a